Here we will study the 8279 Programmable Keyboard Display Interface. So this 8279 is used to interface the keyboard and display to the 8085. Now here this is the 8085 and this is the keyboard and this is the display. And these two are not directly connected to the 8085. In between, these are connected to the 8279 and 8279 is connected to the 8085. Here microprocessor, now by using this, microprocessor will not execute any instructions to interface or to sense the key codes whenever the key is pressed in the keyboard. No need to execute instruction to sense the key codes. So now here automatically whenever the key is pressed, this 8279 itself generate the interrupt signal to the 8085. Thereby what? If the microprocessor is free, then it will read the data from the 8279. So here avoiding the execution of software instructions by connecting the 8279 to the 8085. Now this is a 8279 IC diagram. It is a 40-pin IC. And this is the functional diagram. Functional diagram means what? Total these pins are divided into 4 groups. The pins which are connected to the CPU called the CPU interface. No, all these pins which are connected to the CPU is called the CPU interface pins. And here the pins which are connected to the keyboard called the key data section. Here you can see the written lines. Total 8 written lines are there, along with the shift and the control key, control oblique strobe key. And 4 scan lines are there. And total 8 output lines, port A, port B. Port A is having 4 lines and port B is having 4 lines. Total 8 output lines and 1 blank display line. It will blank the display. So these output lines and blank display line together, it is a display data section, and 4 scan lines are the scan section. Now these are the 4 sections. Now these scan lines are used for the both for display and also for the keyboard. Both it will be used. Now here I will show how the circuit connections are. This is the 8279 and this is the 8085. From the 8085 data lines are coming, and read write is connected to the read write of 8279. Just now we have seen that written lines are there. These written lines are used. Now this is what? This is the programmable interface IC which is connecting the keyboard and display. Now here you can see this is the display, 7-segment display. And these displays are connected to them. Now here you can see output lines. These output lines are driving the, now in each 7-segment display, we have a 7-segment. Now this is the A, B, C, D, E, F, and a dot. Total 8 segments are there. Those segments are driven by using this output data lines. And how many number of segments should be connected, that will be decided by the scan lines. And also here you can see the written lines. Written lines are used for the keyboard. Now here you can see the written lines are in the keyboard section. So keyboard used as a, now in the keyboard, in a matrix keyboard, now here rows are there and columns are there. So for matrix keyboard, these written lines are used as a column lines. And these sensor lines are used as a row lines. And total maximum we can get a 8 by 8 matrix, means what? 64 keys can be obtained by using these scan lines. But here if you see, scan lines are only 4 lines are there. And to get the 8 rows, so we need an external IC which is 3 to 8 decoder. Thereby what? In these 4 lines, it is taking only the first 3 lines and it is decoding and giving the 8 lines over here. Those 8 lines are used as a row lines for the matrix keyboard. Thereby, we can achieve maximum 8 by 8 matrix keyboard. Otherwise, 4 by 8 keyboard. Without this IC, directly by using these 4 scan lines, so we can achieve the 4 by 8 keyboard matrix. Now coming to the display section, now already we have seen these output lines are used to drive these segments, and how many number of 7 segments should be connected, that will be decided by the scan lines. If output this ICD, if we are not using, by using this scan lines, maximum 4 7 segment displays can be connected. So if you want 8, then we have to use the 3 to 8 decoder. In that 8 lines can be used to connect the 8 to 7 segment display. Now if you wanted to extend this up to the 16, so here you have to use the 4 to 8 decoder. If you are using the 4 to 8 decoder, means what? All 4 scan lines are applied to the decoder. Thereby it will give the 16 scan lines at the output. And in this 16, 8 lines are used for the, only 8 lines are used for the keyboard. Now here we can go up to maximum 8 only, 8 by 8 only. And in this 16, the 16 lines you can connect to the output 7 segment displays to display the 16 digits. So this is about the scan line. So connecting the external IC is called, so we can operate the scan lines in 2 modes. One is a encoded mode and another one is a decoded mode. Connecting this external IC is called the encoded mode. Now coming to the decoded mode means what? We are not connecting any external IC. So these least significant scan lines are applied to the internal decoder. Now in this IC, internal decoder is there. So that decoder will decode and it will give the 4 scan lines. Those are 1110, 1101, 1011 and 0111. These 4 lines, these 4 scan lines are available. And by using these 4 scan lines, maximum 4 segment displays can be displayed. And also here the matrix 4 by 8 matrix can be achieved. So this is called the decoded mode. Means what? Without using any external IC, only maximum we can go up to the 4 by 8 and here only 4 LEDs can be displayed. But if you wanted to extend the keyboard keys, and if you wanted to extend the display 7 segment display, then you have to connect the external IC. That may be 3 to 8 decoder or 4 to 8 decoder, depending upon the requirement, how many number of 7 segment displays should be displayed. So if we are connecting the external IC, then that is called the encoded mode. So this is about the circuit, how the circuit connection is. Now we will see the few features of 8279. This is used to interface the keyboard and display. Now it provides a scanned interface to 64 contact key matrix with 2 more keys, control and shift. Now it provides 3 input modes for the keyboard interface. One is a scanned keyboard mode, scanned sensor matrix mode, and strobed input mode. And it has inbuilt hardware to provide the key bonds. And it allows key depression in a 2 key lockout and N key rollover mode. Means 2 key lockout means what? If 2 keys are pressed simultaneously, then which key is pressed first, that will be detected or that will be recognized by the 8279. In N key rollover means if 2 keys are pressed simultaneously, then 2 keys will be stored in the RAM. Or N keys are pressed, then N keys will be stored in the RAM. And here 8279 no need to execute this software polling mechanism here, because it is having the interrupt output pin. Whenever the key is pressed, then 8279 itself generate the interrupt request signal to the 8085. Now here it is having the 8-byte FIFO RAM to store the key codes. Now whenever the key is pressed, that key information is stored in the FIFO RAM. FIFO is nothing but first in first out RAM. Maximum RAM capacity is 8 byte. So 8 locations are there. It provides the 16-byte display RAM to store the display codes for 16 digits. Now, if we wanted to run the maximum 16, now it is having the 16-byte display RAM. So if we are running this 16 displays, then the 16-byte data will be stored in this 16-byte display RAM. If we are using only 8, then the first 8 locations are used. If we are using only 4 7-segment displays, only first 4 locations are used. But maximum is what? 16-byte display RAM is there. And automatic increment address of the display RAM and FIFO RAM is done. So no need to execute the software instruction to increment the this FIFO RAM and display RAM locations. And one more feature is we can operate this in a 2 output modes. One is left entry and another one is a right entry. Means what? Output we can display in this manner and data will be flow in this manner, or data will be flow in this manner. Left entry is nothing but a typewrite type, and right entry is nothing but a calculator type. Now, if you take the calculator, when you are pressing the key, then how the data is displayed in that is nothing but a right entry. So this is about the features of 8279, and this is the block diagram of 8279. Now already we have discussed that total 4 sections. This complete 8279 pins are divided into 4 sections. So now here if you see data bus buffer, IO control, control and timing register, time and control. This is the CPU. Now these 4 together, it is a CPU interface section. And here you can see the written buffer, keyboard bounds, and 8x8 FIFO or sensor RAM, and FIFO sensor RAM status. These 4 comes under keyboard section. Now here this is, you can see the scan lines, scan section, and the remaining these 3 are the display section. Now again we will study the each and every block. Now coming to the first CPU interface. Now first one is a data buffer. Now this data buffers are the 8-bit bidirectional buffers which are used to connect the internal data bus to the external data bus. And the next one is IO control. Now it is having these pins A0, read, write, chip select. These are the signals to control the data flow to and from the various internal registers and buffers. Now inside we have a control register, status register to read the data, to write the data that can be controlled by using these lines. Now coming to the next one, control and timing register. So first I'm explaining the CPU interfacing, control and timing register. Now this is used to store the keyboard and display modes and other operation conditions programmed by the CPU. Now in which mode the CPU want to operate this keyboard? Already we have seen that the 3 modes are there. The first one is a scanned keyboard mode, scanned sensor matrix mode, strobed input mode. So in this, which mode we are operating, that is programmed in this register, and also display right entry, left entry, that also programmed in this. Not only that, other few operations are also written by the CPU in this register. And the next one is timing and control. Now this will generate the timing signal or frequency, clock frequency. Now initially it will generate the 100 kilohertz, and after that this frequency again divided depending upon the operation. Now for example, now keyboard scan time is there, and keyboard bounce time, key scan time, display scan time, and digit on time, blank time, internal. So for that different clocks are required. So those clocks are generated by the timing and control block or unit. And here you can see the one pin that is a display blank. By using this, the display can be blanked. So this is about the interface, a CPU interface blocks. Now coming to the next one is scan section. Now this one, scan section. In this connection diagram, I have explained already. So this we can operate this scan section in two different modes. One is an encoded mode and another one is a decoded mode. What is encoded mode and what is decoded mode? Here I have explained. If we are using the external IC, thereby we are generating the 8 or 16 scan lines for the keyboard or and display purpose, then that is called the encoded. And decoded means what? No external IC is used. So internal decoder is there. With that what? So these scan lines are generated and that will be used for the display and keyboard. Now this is about the scan counter. And the next one is keyboard section. Now here you can see the written lines. Already I explained that these written lines are used for the key as a column lines for the matrix keyboard. Now, if we are using this in the scanned matrix and sensor scanned keyboard or scanned sensor matrix, that time, so if any key is pressed, and for that time we are using the these are using as a columns and the scan lines are used as a row lines. Now in a strobed control, now if we are using in a strobed, that time whatever the data is available on these lines, that data is directly stored in this FIFO RAM. And this keyboard bounce and control unit is used whenever this scanned keyboard mode is whenever this input is operated in this scanned keyboards mode, that time this keyboard bounce section is used. And if any key is pressed, then this keyboard bounce section will sense that, and it will check that if any key is pressed for 10 milliseconds, then that will be the valid key, and it will be considered as a valid key, and it will store that information in this FIFO sensor RAM. And FIFO sensor RAM consisting of total 8 locations and 8-bit data. 8 locations are there and 8-bit data. 3 bits are used for the, now here you can see the written lines are 8 by 8. If they are using the 8 by 8 matrix keyboard, then to represent these 8 lines, 3 bits are sufficient. 2 to the power of 3 is equal to 8 lines. So 3 bits are used for indicating the row, and 3 bits are used for indicating the column, and 1 bit is for the shift, and another 1 bit is for the control. So complete information of these rows, columns, and the shift control bit information is stored in this FIFO RAM. So whenever the key is pressed, that information will be stored in this RAM. Now coming to the FIFO sensor RAM status. If any data is loaded, if this is not empty, means what data is present here, then at the time it will sense the status of this RAM and it will generate the interrupt request signal to the 8085. Now this will go to the 8085. If the 8085 is free, then it will read the data, and 8085 maximum here the data can be stored up to 8 bytes. So if it is till the interrupt signal will be generated, till the RAM is not empty. So this is about the keyboard section. Now coming to the display section, here it is having the 16 by 8 display RAM. So total 16 locations are there, and 8-bit data can be stored over here. And this display address register is used to indicate which location is reading or writing. If the microprocessor is writing the data, or if the data is going to display. So which location is used, that location is displayed by using this display address register. And this display register is the byte which is going to be displayed. That byte is going to be placed in this display before going to display the data that will be stored in this display register. And these are the output data lines which are used to display the data. Now this is about the block diagram of 8279.